solve quadratic inequalities graphically. So let's continue with our series, and this time we have 4 equations here. 2 of them will be solved by me and the other 2 by you. Now in this case they are not in the factored form. So we will actually write these inequalities in factored form and then solve them. So let's start factoring them. The first one is x squared plus 6x plus 5 less than 0. To factor, we're looking for two numbers p and q whose product should be 5, right? And the sum should be how much? 6. So that is what we are looking for. The two numbers are 5 and 1, correct? When you add them, you get 6. So we can factor this as x plus 5 times x plus 1 is less than 0. So that is the factored form of the parabola. Now it's very simple to graph it, right? So let's graph it. Let's say this is our x-axis, and the two zeros are at minus 5, and so the zeros are at x equals to minus 5 and x equals to minus 1. So let us say, and the graph opens upwards since the leading coefficient is positive. So let's draw a graph opening upwards with two zeros. That's the whole idea. So that's the graph, right? Minus 5 will be on the left side, lower than minus 1. Now in this case, it is less than 0. That means these points are not part of solution. So what is the part of solution here? The graph below the x-axis is the part of solution. Do you see that? That is the x-axis. So that is the solution. Now we can write down the solution as x belongs to real numbers, where x is greater than minus 5 and is less than minus 1. And we can also represent this solution on a number line. Let's do that also, right? Let's say this is a number line, and on a number line we'll mark these 2 points, which are minus 5 and minus 1, not including them. So these are the holes, right? And everything in between is a part of solution. So that is the solution on a number line, correct? So this is how we can write down the solution for the inequality which we just solved using graph. Now let's do part B. In part B we have two terms, 2x squared minus 6x, and that has to be greater than 0. Now greater than 0, so let's find zeros first. We can find zeros by factoring. So let's factor. Well, in case it is difficult to factor, you have to use quadratic formula, and then you know where the zeros are, right? So in this case 2x is a common factor, so I'm writing 2x, and we can write x minus 6 divided by 2 is 3, greater than 0, right? So these are the two zeros, and the graph opens upwards, right? So it is like this. Graph is opening upwards, that means like this, right? And the zeros are not a part of solution, and therefore I'll make circle at the zeros. Oh, that means a hole, right? To be precise. Now these holes are at 0 and plus 3. 0 and plus 3. Now what are we looking for? We are looking for quadratic equation greater than 0. So greater than 0 is on from minus infinity to 0 and from 3 to infinity. So that is the part of solution which we are looking for. We can write the solution as x belongs to real numbers, so that x is less than 0 or x is greater than 3, right? So that is how we can write it. On a number line, we can show it like I've shown above, two zeros not including, and then arrows going towards plus and minus infinity from our zeros. Zeros are at 0 and 3, right? So that is how we can show it on a number line. Well, we can also write the solution in coordinate interval form, right? The interval form will be from minus infinity to 0, right? Union from 3 to not including. So that is for not including 3 to infinity. So that is another form in which the same solution can be represented. Good. Now I'd like you to copy the other two questions, C, which is x squared plus 7x plus 12 greater than 0, and D, which is 3x squared plus 6x less than 0. Solve and then move on to the next question. Thank you.